Welcome back students to another session of chapter 10, light reflection and refraction. In the last lecture we studied nature of light, types of mirrors, spherical mirrors and its types and the terms related to spherical mirrors. Now in this lecture we will study rules for reflection through spherical mirror and reflection through spherical mirror with the help of diagrams. So students, now we are going to study the rules for reflection through spherical mirrors. These rules are very important to draw the diagram. If you don't know these rules, you will not be able to draw the diagrams, and 2-mark question will always be there for drawing the diagrams from this chapter. So for this it is very much necessary that you understand these 4 rules for reflection through spherical mirrors. The rules for reflection are same whether it is for a concave mirror or convex mirror. So let us see the first rule. A ray which is parallel to principal axis passes through F after reflection. Here you can see in the diagram A, a ray which is parallel to principal axis after reflection, it is passing through F from concave mirror. In diagram B also you can see that a ray which is parallel to principal axis is getting reflected, and when it is extended backward it is intersecting at point F from convex mirror. So again I am repeating the first rule that a ray which is parallel to principal axis passes through F after reflection. Second rule, a ray which is getting incident on mirror after passing through F will be parallel to principal axis after reflection. In figure A you can see that a ray which is passing through F is getting incident on concave mirror, and after reflection it is parallel to principal axis. And in figure B you can see that a ray is getting incident on convex mirror passing through F, and it is parallel to principal axis after reflection. So this is our second rule, that a ray which is passing through F becomes parallel to principal axis after reflection. Third rule is a ray which is passing through center of curvature will follow the same path after reflection from the mirror. Students, you know why it is? Because if we complete the curve of a mirror, we know that a circle is formed, and if any line is passing through center of the circle, it will be perpendicular to any point of the circle, which means that it will make 90-degree angle with the mirror, right? Now, according to first law of reflection, angle of incidence is equal to angle of reflection. So here angle of incidence is 90-degree. So angle of reflection is also 90-degree, and because of that it is following the same path. Here you can see in the diagram that a ray passing through C is getting reflected from same path from the concave mirror, and in figure B you can see that a ray which is passing through C is getting reflected from same path through convex mirror also. The fourth and the last rule is a ray incident obliquely to principal axis, which means that it is making some angle with the pole of the mirror. It will get reflected by making same angle with the pole as per the first law of reflection, that angle of incidence is equal to angle of reflection. Here in figure A you can see that a ray is making angle I, that is angle of incidence, with pole of concave mirror, and it is getting reflected by making angle R, that is angle of reflection, with the pole, and here I will be equal to R as per the first law of reflection. Same way you can see that angle I is equal to angle R when a ray is getting reflected from convex mirror in figure B. So students, let us revise the rules of reflection. First one, a ray parallel to principal axis will get reflected passing through F. Second one, a ray passing through F will be parallel to principal axis after reflection. Third rule, a ray which is passing through center of curvature will get reflected by passing through center of curvature only, that is C. And the fourth rule, a ray which is making angle I with the pole of the mirror will get reflected by making angle R with the pole such that I is equal to R. These are the four rules of reflection through spherical mirrors. Next topic is image formed by concave mirror. We will see that when object is placed at different positions from concave mirror, where image will be obtained, what will be its size and what will be its nature. Now for this you have to keep in mind that as the object is coming closer to the mirror, its image will be going away from the mirror. This you have to keep in mind, and as image is going away from the mirror, its size is getting increased, except the last case. So first one, at infinity means very far from the mirror. So its image will be obtained at F. Nature will be highly diminished or point like, means very small than the object. Size. And nature will be real and inverted. Next case, object is placed beyond C. So here you can see that from infinity object is coming closer to the mirror, that is, it is beyond C of the mirror. Image will be obtained between F and C, means it is going away from the mirror. Initially it was at F, now it is obtained between F and C. Size is diminished, that is smaller than the object, and nature is real and inverted. The third case is when object is placed at C, that is again closer to the mirror. Image will also be obtained at C, that is going away from the mirror compared to earlier case. Size will be same as the object and nature will be real and inverted. Fourth case is between C and F. Image will be obtained beyond C. It will be enlarged, or you can say magnified, and nature is real and inverted. Next case is object is placed at F. Image will be obtained at infinity. It will be highly enlarged, that is size will be highly magnified, very big compared to object, and nature is real and inverted. Now the last case, which is the exception, that is when object is placed between P and F, image will be obtained behind the mirror and it will be enlarged, that is magnified in size, bigger than the object, and nature will be virtual and erect. So this is the only case for the concave mirror where you are getting virtual and erect image, and that is when object is placed between P and F of concave mirror. Now we will draw the diagrams by placing the object at all these positions, and we will get the image of the object. Now one thing you have to keep in mind, that while drawing the diagram, pole P should be at the center of reflecting surface of mirror as per the definition. How much distance is there between P and F? Same distance should be there between F and C. So when you are drawing the diagram, you have to be particular that distance between P and F and C should be same. So now let us draw the diagrams. Here I have taken 2 centimeter. You can take any distance, but you have to keep in mind that distance between P and F and C should be same. Next is the image is formed by convex mirror. When object is placed at different positions, we'll see that where image will be obtained, what will be its size and nature. First of all, when object is placed at infinity, image will be obtained at F, but this F will be behind the mirror, since convex mirror forms virtual image and it is obtained by extending the reflected ray backward. So it will be at F but behind the mirror. Size will be highly diminished or point like, and nature is virtual and erect. Second case is between P and infinity, that is you can keep your object anywhere between pole and infinity. the position of the image will be same, that is it will be obtained anywhere between P and F of the mirror, which will be behind the mirror. Size will be diminished and image will be virtual and erect. Now students, we will learn how to draw the diagrams. First of all, for drawing the diagrams you have to write the detail, that where object is placed, where image is formed, nature and size. So first of all, we will consider the first case in which object is placed at infinity, image is obtained at F, the nature is real and inverted and size is point-like. Now we will see how to draw the diagram. First of all, when object is placed at infinity, the rays coming from the object are parallel to principal axis. So now we will see how to draw the diagram. First of all, for drawing the diagram, we have to draw the concave mirror like this, and this represents the polished part of the concave mirror this way. Now we will draw the rays. Now object is at infinity, so the ray coming from the object will be parallel to principal axis. So this is your incident ray, and we know the first rule, that when the rays are parallel to principal axis, they pass through F after reflection. So here you can see that it is passing through F. Similarly, we will consider the another ray which is passing through parallel to principal axis. So this is the ray which is parallel to principal axis, and you can see that after reflection it is passing through F. So here both the reflected rays are meeting here, that is at point F. So image of the object is formed at point F, and you can see that it is point-like. Now one more thing you have to keep in mind, that whenever you are drawing the diagram, you have to represent the direction of the ray. Here this represents the direction of incident ray, this represents the direction of reflected ray. This is the direction of incident ray and this is the direction of reflected ray. This you have to draw. It is very much necessary because it represents which is incident ray and which is reflected ray. If you have not drawn the diagram, rays, then no one will be able to know which is incident ray and which is reflected ray. So these arrows representing the direction are very much necessary. So students, now let us study how to draw the second diagram. In the second case, object is placed beyond C, that is center of curvature of concave mirror. Here you can see that object AB is placed beyond C of center of curvature. Now first of all, for drawing the diagram, we will draw the concave mirror. This is the reflecting surface of the concave mirror. Now this is your object AB and this is point A of the object. Now we will consider two rays which are passing through point A of the object. First of all, let us consider the ray which is parallel to principal axis, and according to rule 1, the ray which is parallel to principal axis passes through F after reflection. So here you can see that this is your incident ray which is parallel to principal axis and this is reflected ray which is passing through F. Now we will consider the second ray from the same point A of the object. This is your second ray which is passing through center of curvature C from point A of the object. Now this is your incident ray. Now we know that when a ray is passing through center of curvature, it is reflected from same path. So this is your reflected ray, and the direction of reflected ray is this same path. Right? Now this both reflected rays are meeting here. Here you can see that they are meeting. So this is the image of point A, that is A dash of the object, and if we extend it to principal axis, you can see that image B dash can be formed. So here A dash B dash is which kind of image? Real and inverted. You can see that it is inverted image, and what is the size of the image? Diminished, that is smaller than the object. So this way you have to draw the diagram when object is placed beyond C, and you have to write all these 4 points also, that is position of the object, position of the image, nature of the image and size of the image. Now let us learn how to draw the third diagram. In the third case, object is placed at center of curvature C of concave mirror. Image is obtained at C. Nature is real and inverted and size is same as object. So first of all, for drawing the diagram, we have to draw the concave mirror. This is the polished surface of the concave mirror. Now this is your object AB, which is placed at C. Now we will consider two rays from point A of the object. The first ray, which is parallel to principal axis, and we know that after reflection it is passing through point F. So this is your reflected ray, this is incident ray and this is reflected ray. Now we will consider the second ray from point A of the object, which is passing through F focus. And we know according to second rule that when ray is incident on mirror, after passing through F, it becomes parallel to principal axis after reflection. So this is your reflected ray. This is incident ray and this is reflected ray, and you can see that this both rays are meeting at point A. So A dash. So A dash is the image of point A of the object. Similarly, we can obtain A dash B dash, which is the image of object AB, and you can see that here size of image is same as size of object. Now students, keep in mind that this diagram, it is very important that size of image and size of object should be same when you are drawing this diagram, and image should be obtained exactly at point C. Now the fourth case. In the fourth case, we know that object is placed between C and F. Image is obtained beyond C, nature is real and inverted and size is magnified. Magnified means bigger than the object. So here you can see that object AB is placed between F and C of concave mirror. So first of all, draw a concave mirror and draw object AB between F and C. Now we will consider two rays from point A of the object. First ray, which is parallel to principal axis, and you know that after reflection it passes through F. So this is your incident ray and this is your reflected ray. Now another ray which is passing through center of curvature. So you can see that this is the ray which is passing through center of curvature, and we know that if it is passing through center of curvature, it gets reflected from same path. So this is your incident ray and this is your reflected ray, and you can see that both these rays are meeting here, that is at point A dash. So A dash B dash is real and inverted image of object AB when object is placed between F and C, and here you can see that size of image is bigger than that of the object. Now next case. Object is placed at focus, that is at F, and we know that when object is placed at F, image is obtained at infinity. The nature is real and inverted and size is highly magnified, means much more bigger than the object. So let us draw the diagram. First of all, concave mirror. Object AB is placed at F of the concave mirror. Now consider first ray from point A, which is parallel to principal axis. We know that it is passing through F after reflection. So this is your incident ray and this is your reflected ray. Now another ray which is passing through C of the mirror, that is, this is your incident ray and this is your reflected ray from the same path. So this is incident ray and this is reflected ray, and the image is obtained at infinity. So we won't be able to get the image over here because it is obtained at infinity and its nature will be highly magnified. So this is the diagram for the object which is placed at f of concave mirror. Now the last diagram for the concave mirror, that is object is placed between P and F of concave mirror. Image is obtained behind the mirror, size is magnified and nature is virtual and erect. Students have to keep in mind that this is the only case for the concave mirror in which virtual and erect image is obtained. In all other cases, the image obtained is real and inverted. So first of all, let us try to draw the diagram. Draw a concave mirror. Now consider a ray which is parallel to principal axis from point A of the object. So this is the incident ray and it is getting reflected after passing through F. So this is your reflected ray. Now second ray which is passing through center of curvature. So this is the ray which is passing through center of curvature and it is getting reflected from same path. So this is incident ray and this is reflected ray. Now you can see that they can't meet in front of mirror. So we have to extend this rays backward. So this ray is extended like this and this ray is extended like this, and you can see that they both are meeting here. So this is the virtual and erect image of object AB which is obtained behind the mirror, and you can see that it is magnified image. Now first diagram for the convex mirror, that is object is placed at infinity. Now when object is placed at infinity, the rays coming from the object are parallel to principal axis. You know it. And another thing which you know is that convex mirror gives virtual image. That is, the rays after reflection cannot meet. They will meet when they are extended backward. So now let us try to do the diagram. First of all, object is placed at infinity, image is obtained at F. Nature is virtual and erect and size is point-like, or you can say highly diminished, means very small than the object. So first of all, draw a convex mirror. Now you can see that this is the convex mirror and this is the polished, representing the polished surface of the convex mirror. Now we'll consider the first ray which is parallel to principal axis. Now you know that this ray is parallel to principal axis and after reflection it is getting reflected like this way. Now consider another ray which is parallel to principal axis. So this is the ray which is parallel to principal axis and it is getting reflected this way. Now this reflected rays cannot meet. So what we will do, we will extend both this reflected rays this way. So this way, and this is extended like this. So you can see that this both are meeting here, which is F, that is the focus of convex mirror. So this way you have to draw the diagram for convex mirror. Now let us say the second case. Object is placed between infinity and P of the convex mirror. Now here between infinity and P means you can keep your object anywhere. Because of this only there are only two cases in the convex mirror, that is when object is placed at infinity and then object is placed anywhere between P and infinity. Why? Because if you keep the object anywhere between P and infinity, that is at C or between F and C, anywhere, the nature of the image will be virtual and erect and size will be diminished. So here only two diagrams are there, and where image will be obtained, it will be obtained between P and F. So now let us see how to draw the diagram. First of all, draw the convex mirror. Now, consider the first ray coming from point A of the object. So, this is your incident ray. It is parallel to principal axis, so it will get reflected like this. This is your reflected ray. Now, if you extend this reflected ray, we know that it will be meeting at F. So, this is your F. Now, we will consider the second ray which is passing through C. So, this is the ray which is passing through C. This is incident ray and this will be the reflected ray also, because we know that incident ray and reflected ray follow the same path when they are passing through C. Now you can see that this both reflected rays are meeting here, that is at point A dash. So A dash B dash is virtual and erect image of object AB, which is placed between P and infinity of convex mirror, and you can see its size, it is diminished, which means that smaller than the object. So students, in this lecture we studied rules for reflection, table showing the position, nature, size of image when object is placed at different positions from concave and convex mirror, and we show the ray diagrams for each and every position for concave and convex mirror. This topic is very important. Again, I am repeating that 2-mark question is asked for drawing the diagrams. So here you have to draw all the diagrams in your notebook and you have to practice 2 to 3 times each diagram. This is the task given to you in this lecture. That's all for this lecture. We'll continue with other topics in the next lecture.